In this example, we're going to look at the dihedral angle between two planes which are not intersecting. So just to give you the kind of general setup here. So over on my left hand side here, I've got a plane A, B and C. There's my elevation and there's my plan. And over on the right hand side, I've got another similar plane, ABC elevation and ABC on the plan. So they don't actually intersect, but I want to still achieve the common angle or the dihedral angle between both planes. Okay? Now, before I do that, we need to know that a geometric theorem tells us that all planes containing a line perpendicular to another plane are themselves perpendicular to the other plane. If two lines, one perpendicular to one of the given planes and the other perpendicular to the other given plane, intersect at a given point, they determine a plane perpendicular to each of the two given planes. In other words, I'm going to try and create a common plane to these two here, because we said in the last example that the dihedral angle is a third plane perpendicular to two planes. Okay, so the procedure is as follows. Step number one, from the plan here, I'm going to take a level line. Okay, so I've got my point N, I project it up to my elevation, and there, because it's on the line BC here, it'll be on the line BC here. Therefore, that there is my line, and it's also a true length because this is parallel to the XY line, therefore the projections of which is a true length. I do the exact same thing over here. I draw a line parallel to the XY line, I project it up, and from B I get another line. In this case, this is my true length. So now I've got two true lengths. I do the same thing the opposite way. I take a level line on the elevation, I project it down to the plan, I get a true length of a line. Likewise, I do the same over here. I draw a level line with my t-square, I get point N, and I bring it down here, and I get another true length. So now I've got four true lengths on my picture, okay, on my sheet. So now what I'm going to do is forget about those two planes. I'm going to pick a point P at random. So P is picked at random on the plan, and it's also picked at random up here. So from P here, I'm going to draw a line perpendicular to my true length here. I'm also going to draw another one here, a line perpendicular to my true length here. So I've got two lines which are perpendicular to two true lengths here. I do the exact same over here. From point P, I'm going to draw a line perpendicular, okay, to the true length, and over here I'm going to draw a line perpendicular to the true length. Okay, so I've got two lines going in two different directions and two different directions. So now what I want to do is I want to create a plane out of that situation here. And all I do to create a plane, well, I have two lines. I need a third line for a plane. 3 points make up a plane. I have point P, okay, and I've got a line here and here. So if I take a level line here with my t-square, now I've got a plane. So there's my plane, P, 1, 2. 1 is projected down here onto this line, and 2 likewise. So down here I've got my plan of my plane, but I've also got a true length of a line, points 1 to 2, because this is parallel to my XY line. Okay, so all I'm going to do now is find the true shape of that triangle or that plane, and it's the same procedure as before. I'm going to look along the true length, okay, and I know what happens when I look along the true length. I'm going to get a point view. Now I put in a datum line here, so in other words, rather than stepping the heights here, I just put in a datum line along the line 1, 2. Okay, so when I project out here, I set up an x1, y1 perpendicular to my true length. I project out point 1 and 2. Okay, there's point 1 and 2, and point P, it'll be projected out, and point P is that distance off the ground. So now what I have here is I've got points 1, 2 and P. Okay, I've got the edge view of that triangle or that plane. Now what I'm going to do is I'm going to simply look directly at that edge, and I know a property of looking along an edge or looking at an edge is always going to be a true shape of the surface. Okay, so when I project out 1, 2 and I project out point P, I need to know where do I get these distances from. Well, it goes back to what I said before about here I've got horizontals or elevations, verticals I have plans. Down here I've got, there's my plan, there's my vertical, there's my horizontal, and over here I've got the vertical and horizontal. So that must be a plan view. Okay, therefore this is a plan view, so therefore they must be related in some way. In other words, that I put on a datum line here, Okay, it's because I'll run off the sheet. So therefore, the distance from my datum line, which is taken through point 1, that distance there will be that distance there. Point 1 happens to be on the datum line, so there's number 1. And number 2 is that distance away, and that's my distance. So down here, I've got the true shape of the triangle P12. It is also the dihedral angle between the two planes, because we said that the dihedral angle is a third plane perpendicular to two planes. In other words, that the angle that this triangle here plane is perpendicular to that. It's also perpendicular to that. Okay, and again, I've just extended the two lines here to show that the dihedral angle, we've got one angle here and we've got another angle here. Okay, and then finally we have another alternative way, and again we did it on the previous sheet. There's my edge view of my triangle 1, 2 and P. So if I swing this down here, bring it all the way back here, okay, and simply bring P out parallel to the datum line, or parallel to this x1 y line, or perpendicular to that line. Therefore, there is my dihedral angle, or the true shape of 1, 2 and P here. That's the true shape. It's also the dihedral angle. Okay, thank you.